You were told the moon race was simple. America landed, the Soviets lost, and the story ended there. But behind that clean version was a hidden Soviet lunar program, filled with secret failures, real moon hardware, robotic missions, and discoveries that made the moon look far stranger and more important than the public was ever told. The real story is that the Soviet Union built a serious lunar program with heavy rockets, robotic probes, lunar orbit missions, and even a real plan for a human landing. In 1959, Luna 2 became the first human-made object to reach the moon. Then Luna 3 gave humanity the first images of the far side. In 1966, Luna 9 made the first soft landing on the moon. That same year, Luna 10 became the first spacecraft to orbit it. Those are not small achievements. That is the record of a country pushing hard into lunar exploration. So the obvious question is this. If the Soviets were doing all of that, why do so many people remember the story as if they never really tried? The answer starts with secrecy. The Soviet system was built to show success and hide failure. That matters because moon missions fail all the time. Rockets break apart, guidance systems go off course, engines shut down, radios stop working, probes miss their target, landers crash. That is normal in early space exploration, especially when you are trying to do something as difficult as reaching the moon. The United States had failures too, and many of them happened in public. The Soviet Union handled it differently. If a mission failed early, the public often heard little or nothing. Sometimes outsiders had to guess what the launch was even supposed to be, and that is where the fog begins. When a launch disappears into silence, people start filling the gap themselves. Was it part of a hidden lunar plan? Was it a mission that failed so badly the state did not want anyone to know? In many cases, the most likely answer was simple. It was a space failure that the Soviet system chose not to explain. But when enough of those unexplained failures build up, the whole program starts to look mysterious from the outside. The mythology does not begin with evidence of something strange on the moon. It begins with a government refusing to talk clearly about what went wrong on the way there. Then you get to the most important piece of the hidden story, the N-1 rocket. This was the giant at the center of the Soviet crewed moon effort. It stood about 105 meters tall and carried around 2,700 tons of propellant. This was the vehicle meant to send Soviet cosmonauts toward the moon. It was their answer to Saturn V, but the design was very different. Instead of using a small number of very large engines in the first stage, the N-1 used 30 smaller engines packed together. In theory, that could produce enough thrust. In practice, it made control incredibly difficult. The rocket had to keep all of those engines working together under enormous stress, and the system had very little room for error. So what happened? The N-1 flew 4 times between 1969 and 1972, and all 4 launches failed. The worst failure came in July 1969. The rocket lifted off, ran into the trouble almost immediately, fell back and exploded with such force that it destroyed the launch pad. This happened only weeks before Apollo 11. That timing matters. While the United States was closing in on the first human landing, the Soviet moon rocket was destroying itself on the ground. That is not just a technical failure, that is a disaster. And it is exactly the kind of event the Soviet system did not want the world to see clearly. So when people ask what the Soviets were hiding, the first honest answer is not a strange object on the moon. It is collapse. It is the collapse of confidence in the vehicle they needed most. Because no matter how good your spacecraft is, no matter how skilled your engineers are, if your moon rocket cannot leave Earth reliably, your entire lunar plan starts to fall apart. Then the story gets worse. The program was not just struggling with hardware, it was also struggling internally. After Sergei Korolev died in 1966, the Soviet lunar effort became more fragmented. Korolev had been one of the central figures behind the early Soviet space successes. After his death, rival design bureaus competed more aggressively. Priorities became less clear. Instead of one unified push to the moon, the program became more divided. That division made every failure harder to recover from. This is important because it changes how you read the silence. The Soviets were not hiding a smooth secret program that was succeeding in the dark. Very often they were hiding a program that had real achievements, real ambition, and real hardware, but was also becoming unstable. Their robotic moon missions were strong. Their crude lunar architecture was much more fragile. That is a very different story from the one most people grow up hearing. The usual version says the Soviet Union simply lost. The deeper version is that it built a real path to the moon, pushed hard, got closer than many people realize, and then could not openly admit how badly that path was breaking. So why does the official story still feel so clean? Because the gaps were left there on purpose. Some launches were barely acknowledged, some failures were hidden behind vague announcements or complete silence. Some parts of the lunar program stayed out of public view for years. When later generations looked back, they saw the American landing clearly because it happened in front of the world. The Soviet side looked smaller, partly because so much of its struggle had been buried. That missing history makes the whole race look simpler than it really was, and once you understand that, the tension changes. The question is no longer just who landed first. The question becomes, how much of the moon race did the public never really see? How much of the Soviet effort was lost inside a system that could not admit weakness? And how many later moon myths grew out of that silence instead of out of real evidence? That is why this story matters. You do not need invented ruins or fake conspiracies to make it intense. The real history is already strong enough. A superpower built a secretive lunar effort. It scored major robotic victories. It developed a real crude moon plan. It built a giant rocket that kept failing. And instead of explaining the full truth, it allowed large parts of that story to disappear into silence. That silence is the foundation of everything that comes next. Because once a state hides the failures, every unanswered question gets heavier. And once the public realizes the official version was incomplete, the next question becomes much harder to ignore. If the Soviets were already hiding the truth about their race to the moon, then what did they learn when they finally started studying the side of the moon that Earth never sees? The far side of the moon sounds familiar now, but for most of human history it was a complete unknown. You could look at the moon your whole life and never see that other half. So when the Soviets sent Luna 3 around the moon in October 1959, they were not just taking pictures, they were removing one of the biggest blanks in space science. And what came back was strange enough to change the whole story. The images from Luna 3 were crude. They were blurry, low in contrast, and hard to read by modern standards. You would not mistake them for the kind of sharp lunar photography we have now, but that does not reduce what they meant. For the first time, humanity could see the hemisphere of the moon that never faces Earth. That alone was historic. And then Soviet scientists started building maps from those frames, and the real shock appeared. The far side did not look like the moon people thought they knew. From Earth, the near side of the moon is defined by dark plains. Those broad dark regions are ancient lava fields called Maria. They stand out clearly even to the naked eye. They shape the moon's familiar face. People were used to that pattern. They assumed the far side would be broadly similar. It was not. Luna 3 showed a surface dominated much more by bright, heavily cratered highlands. The big dark Maria that defined the near side were mostly missing. New regions had to be identified. New features had to be named. The moon that seemed familiar turned out to be only half understood. That is why this was more than a propaganda win. It was a scientific break. The old mental picture of the moon stopped working the moment the far side came into view. The Soviets had not just photographed hidden terrain. They had exposed the fact that the moon was uneven in a deep and important way. And that leads to the next problem. Why would one half of the moon look so different from the other? Why should one side have large volcanic plains and the other side be dominated by older, rougher crust? That was not a small detail. It pointed to a much bigger issue inside the moon itself. Some of the most important features from those early far side views made that difference obvious. Mare Moscoviense stood out because it was one of the few major far-side Maria. Tsiolkovsky crater also drew attention because of its dark floor, showing that volcanic material had been there too. But those examples only made the imbalance more striking. If volcanic flooding could happen on the far side, why did it happen so much less there? Modern science gives a clearer answer than the Soviets had at the time, but the core mystery began with their images. The far side appears to have a thicker crust on average, thicker by tens of kilometers. That matters because when crust is thicker, magma has a harder time breaking through to the surface, so even if heat and molten material existed deeper down, the far side was less likely to be covered by wide basalt plains. The near side, with thinner crust in key regions and different internal conditions, was more open to ancient volcanic flooding. That means Luna 3 was not simply showing new scenery, it was opening a geophysical problem. The Moon's two hemispheres were recording different internal histories. Then there is the other reason the far side mattered so much. It was not just visually hidden, it was operationally difficult. The far side is cut off from direct radio contact with Earth. Once a spacecraft passes behind the Moon, it disappears from direct communication unless you have relay support. That changes everything. A near-side mission can talk to Earth continuously in the right conditions. A far-side mission cannot. So the far side was not only harder to study, it was naturally harder to monitor, harder to command, and easier for outsiders to speculate about. That is one reason the far side became such a magnet for rumour. In the Cold War, a place already hidden from sight and also hidden from direct radio contact was always going to attract stories. If something happened there, Earth would not hear it live. That sounds like the perfect setup for conspiracy thinking, but the real science is stronger than the rumour. The far side is shielded from Earth's radio noise, and that makes it one of the best places in the inner solar system for low-frequency radio astronomy. Signals from our own planet drown out some of the faintest parts of the radio universe. The far side blocks that interference. So the same place that sounded secretive was also valuable for scientific reasons. It was naturally quiet. That matters because it changes the meaning of Soviet interest. They were not just dealing with a hidden side in the visual sense. They were dealing with a side of the Moon that had different engineering demands and different scientific value. Communication was harder, mapping was harder, landing would be harder, but the reward could also be greater. And this is where the stakes rise. Luna 3 was not just a first glimpse into hidden terrain, it was one of the first real signs that the Moon was not symmetrical. That sounds simple, but it changes almost everything. Once one hemisphere is different from the other, you are no longer dealing with a uniform world. You are dealing with a world whose history is written unevenly across its surface. Later missions made that much clearer. Scientists eventually built a much deeper picture of the Moon's asymmetry. The far side includes the enormous South Pole Aitken Basin, one of the largest impact structures in the solar system. The distribution of Maria is heavily biased toward the near side. The crust is not the same thickness everywhere. The internal distribution of heat-producing elements is uneven. All of that points to a much more complicated lunar history than older simplified models allowed. But the first serious blow against the old simple Moon came when the Soviets showed that the far side was not just more of the same. So when people ask what the Soviets were hiding on the Moon, this is one of the strongest answers. They were not hiding a monster. They were uncovering a different Moon than people expected, and the implications were bigger than the pictures themselves. The far side was geologically different, harder to reach, harder to communicate with, and scientifically more revealing than anyone had assumed. Once that became clear, lunar exploration stopped being one simple project. It became several problems at once. Where could you land safely? Where could you keep contact with Earth? Which regions told the real history of the Moon's interior? And if one half of the Moon formed such a different surface, what did that say about the violent processes that shaped it? That is the real shift in this part of the story. The Soviet Union did not just reveal a hidden face, it revealed that the Moon was more complex than the public had been taught to think. The far side was not just the side you could not see, it was the side that showed the Moon had a deeper history, and that history was uneven, technical, and full of consequences. And once the Moon stopped looking simple, another problem appeared. If this world was not a dead uniform rock, then what else was wrong with the old picture? Because the next thing the data started to suggest was even harder to ignore. The Moon was supposed to be quiet, but the evidence was starting to show that it was not. The Moon was supposed to be dead, so why did it keep acting like it was still active? For a long time, people talked about the moon like it was finished. No air, no weather, no oceans, no life, no geology worth worrying about. Just an old surface full of craters frozen in time. That was the simple picture. And it sounded reasonable. The moon looks quiet. It looks empty. It looks like nothing much should be happening there anymore. But once real instruments started collecting real data, that simple picture started to break. One of the biggest problems was that the moon kept shaking. Seismic instruments later used during the Apollo era detected deep moonquakes far below the surface, shallow quakes much closer to the top, cracking, caused by temperature changes, and signals from meteoroids hitting the ground. Some of the deep quakes repeated in patterns linked to Earth's gravity pulling on the moon. That matters because it means the moon was not just sitting there as a perfectly inert object. It was responding to stress. It was still moving internally in ways that mattered. Not like Earth, with active plate tectonics and constant volcanic resurfacing, but not like a totally dead rock either. That point changes the whole mood of lunar exploration. If the moon can crack, flex, and respond to tidal forces, then you're not landing on a simple museum piece. You're landing on a body that still has physical behavior. And Soviet scientists were working in exactly that period, when the old idea of a completely dead moon was already starting to come apart. Then there was the surface itself. People often talk about lunar dust as if it is just powder lying on top of rock. It is much more than that. The lunar surface layer, called regolith, is the product of billions of years of impact damage. Tiny meteoroids, large impacts, shattered rock, melted glass, broken mineral grains, and fine electrostatically active particles all got processed into that upper layer over immense spans of time. It is not ordinary soil. It is the result of constant bombardment, and that has consequences. The size of the grains matters. The way the particles stick together matters. The load-bearing strength matters. The slope stability matters. The way a lander foot sinks matters. The way a rover wheel slips matters. The way a drill bites into the surface matters. Very quickly, both American and Soviet missions learned that the moon's surface was not just something you stand on. It was something you had to understand scientifically and mechanically at the same time. That is one reason the lunar and Lunokhod missions mattered so much. They were not only reaching the moon, they were testing how the surface actually behaved under stress. When a rover moved, it was also measuring traction, sinkage, and soil response. When a lander settled, it was also showing engineers what that patch of regolith could support. Some areas turned out to support loads better than people feared. Others were less predictable. That sounds technical, but it changes the story in a serious way. The moon's surface is not passive scenery. It is an engineering problem built out of the wreckage of early solar system history. Then another complication appeared. Even the idea of the moon as a perfectly sealed, inactive world started to weaken. For centuries, observers had reported brief strange events on the moon, short glows, hazes, flashes, or local changes in brightness. Many of those reports are weak, inconsistent, or probably mistakes, but not all of them became easier to ignore once later evidence suggested that gases could still escape from the lunar subsurface in some regions. Radon release became part of that discussion. That does not mean the moon is alive in the way a planet like Earth is active. It does mean the moon may not be as sealed and static as older models assumed. And that matters because once you admit even limited outgassing or localized release of material, every unusual region starts to look more important. Every anomaly becomes harder to dismiss immediately. Every strange report gets re-evaluated. Soviet scientists did not need to believe wild stories to take that seriously. They only needed to understand that the moon was not behaving like a perfectly closed object. If gases can move, if localized activity can happen, even at a low level, then the moon is more dynamic than the old public image allowed. There is another reason this mattered so much. The moon preserves evidence extremely well. On Earth, geology erases itself. Wind reshapes land, water moves sediment. Plate tectonics destroys and recycles crust. Volcanoes bury older surfaces. Forests grow, rivers cut, ice advances, coastlines shift. Earth is bad at keeping its oldest visible record intact. The moon is different. No atmosphere, no rain, no rivers, no active crustal recycling on that scale. So when something hits the moon, the evidence can stay there for an incredibly long time. That turns the moon into a kind of long-term record of impact history. Crater counts became one of the major ways scientists estimated the ages of surfaces across the moon and later across other worlds too. Basalt plains, ejecta blankets, broken rocks called breccias, and tiny impact glass particles all became time markers. They helped scientists reconstruct the history of bombardment in the inner solar system. That means when Soviet missions brought back samples or drove across Mare terrain, they were not just collecting random dirt and rock. They were sampling history itself, preserved in a place where very old events had not been erased. This is where the story gets bigger than the race for first place. The moon was no longer just a destination where a superpower wanted to plant symbols. It was becoming a scientific archive, a body that stored evidence about impacts, volcanism, crust formation, and the violent early history of the solar system. And the more data came in, the less the old simple moon survived. That is the real escalation here. The hidden revelation was not just that the Soviets were still studying the moon. It was that the moon they were studying was more complicated than the public story ever suggested. It could shake. Its surface could behave in difficult and sometimes deceptive ways. It could preserve traces of events older than most of Earth's visible geology. It may even have limited gas release from below the surface. Piece by piece, the moon stopped looking like a dead trophy and started looking like a system. And once you see it that way, a lot of Soviet behavior makes more sense. They were extracting information from a world that was turning out to be far more valuable scientifically than outsiders fully understood. That kind of knowledge does not always make headlines. It does not always fit into a clean Cold War narrative. But it matters. Because once a superpower realizes the moon is not just symbolic, the whole logic of going there starts to change. So when you ask what the Soviets were hiding on the moon, one answer is this. They were helping uncover evidence that the moon was not a finished, simple object at all. It was physically active in limited but important ways, mechanically difficult, scientifically rich, and full of records that Earth could no longer preserve. That is not a minor correction to the old story. That is a different moon. And once the moon stopped looking dead, another question became unavoidable. If it was this complex, and if it was this valuable, then how serious were the Soviets really about putting a human being on its surface? Because the next part of the story shows something many people still do not understand. They had a real moon landing plan, and it was much closer to reality than most people know. The Soviet Union did have a real plan to land a human on the moon. And once you look at that plan closely, the first thing you notice is how little margin it had. A lot of people still think the Soviets never had a serious crewed lunar program, as if they only talked about it in theory and never built anything real. That is wrong. They had a real architecture, real hardware, and a real mission concept. The system was called L3. It was the Soviet lunar expedition stack built around two main spacecraft. One was the 7KLOK, which would stay in lunar orbit. The other was the LK, the lander, that would take a cosmonaut down to the surface and bring him back up. This was not a rough sketch. It was an actual attempt to solve the problem of landing on the moon, with the mass and launch limits the Soviets were stuck with, and that is where the danger starts. Apollo sent 2 astronauts down to the lunar surface. The Soviet plan sent 1. One person would descend alone, land alone, work alone, lift off alone, and then rendezvous again in lunar orbit. Right away, the difference is obvious. Less redundancy, less support, fewer backup options, less room for anything to go wrong. This was not simply a smaller version of Apollo. It was a much tighter and harsher system. So why was it built that way? Because the rocket forced it. The N1, which was supposed to launch the Soviet lunar mission, did not give them the same payload freedom that the Americans had with Saturn V. The Soviet lander had to be compact because every kilogram mattered. The LK was stripped down to the essentials. It had to descend, support a very short surface mission, and then rise back to orbit with the absolute minimum mass possible. That shaped everything about the design. Crew volume was limited, time on the surface was limited, Operational freedom was limited. Even the basic experience of being inside the vehicle would have been more constrained and less forgiving. That changes how you should picture the mission. The Soviet cosmonaut was not going to step into a roomy, flexible lunar system with plenty of backup support. He was going to operate inside a tightly optimized machine under strict time pressure with a small resource envelope. A short stay, a narrow sequence, a lot of things that had to work correctly the first time. The mission was not impossible. That is the important part. It was real and technically serious, but it was built in a way that gave bad luck very little room. Then the plan gets even more severe. Apollo crews could move between spacecraft through an internal tunnel after docking. The Soviet architecture was rougher. Because of the way the vehicles were arranged, the cosmonaut would likely have had to do an EVA transfer in lunar orbit. That means before the landing even starts, the mission already includes an extravehicular operation in space just to move from one vehicle to another. Then that same person has to descend to the moon, work on the surface, lift off and in, and dock once more in orbit. Think about that mission sequence in plain terms. You leave Earth, you travel to lunar orbit, you go outside in space to transfer, you land alone on another world, you work there in a suit with limited time, you launch back up alone, then you dock again in lunar orbit. That is a severe chain of events even by the standards of the moon race. Every extra step adds risk. Every exposure event adds another place where the mission can fail. Because this was a one-man surface mission, there was no second person on the ground to help solve a problem in real time. That is what makes the Soviet plan so striking now. It was not unrealistic in the sense of being fantasy. It was realistic in a much more uncomfortable way. It was a mission design that accepted very high risk because the system had no easy way to become larger, safer or more forgiving. It had the discipline of serious engineering, but it also shows how much pressure Soviet planners were under. They were trying to reach the moon with less mass margin, less system flexibility, and less ability to absorb failure. And all of that depended on one thing above all else: the N1 rocket actually working. That was the bottleneck. No lunar architecture matters if the launch vehicle cannot reliably leave Earth. The Soviets could design orbiters, landers, and mission sequences, but none of it could become history without the N1. And the N1 never became reliable. It failed 4 times. Some failures involved control logic. Some involved engine shutdown cascades. Some involved plumbing problems. Some involved damage caused by debris in a system already too complicated for comfort. The first stage was especially demanding because it relied on 30 engines acting in coordination. That clustering approach was not automatically doomed, but it created a very difficult control problem under enormous stress. The Soviet program did not end up with a giant engine path like the one used by the Americans. Instead, the lunar mission inherited the propulsion and institutional limitations of the Soviet system. After Korolev's death, that system became more fragmented. The result was that the moon landing plan depended on a rocket that never gave the program the stable foundation it needed. And once the N1 kept failing, the whole crude lunar path started to collapse. That is the hidden damage. Not just one rocket exploding, not just one launch lost. The collapse of the entire route to a Soviet human landing. Because when your mission is already thin on margin, and then your booster becomes unreliable, the architecture does not just become delayed, it becomes stranded. This is why the public silence matters so much. Most people never saw this as a near history. They saw it as absence. They assumed the Soviets did not really get close, but they did get close enough for the failure to matter, close enough for hardware to exist, close enough for test flights to happen, close enough that if a few major technical problems had broken the other way, the world might have seen one of the boldest lunar missions ever attempted. The LK lander itself is the clearest proof of that. This was not a paper vehicle with no physical reality. It flew in test contexts in Earth orbit. The program advanced far enough that you can no longer dismiss it as unrealized talk. Metal was built, systems were evaluated, procedures were worked through. The Soviets had crossed the line from dreaming about a landing to preparing for one. That is what makes this section so important. The thing they were hiding, was not an imaginary secret on the moon. It was a dangerous and very real mission path that nearly entered history and then failed behind closed doors, and that failure changes the meaning of the entire moon race. It means the Soviet Union was not simply standing outside the door while America walked through it. It means the Soviets had built their own door, but it was narrower, harder, and far more fragile. Their lander was smaller, their mission sequence was harsher, their crew support was weaker, their rocket was unstable, but it was still a serious attempt, and that makes the silence around it much more revealing. Because the more you look at the hardware and the mission plan, the harder it is to keep believing the simple version of events. The Soviet lunar effort was not fake. It was not symbolic. It was not a bluff. It was a real attempt to land a human on the moon with a system that demanded extreme precision and accepted extreme risk. When it failed, what disappeared from public view was not just a technical program, it was an entire branch of possible history. That is one of the most important things the Soviets were hiding. Not a moon base, not a secret civilization. A real lunar landing plan that came close enough to become frighteningly plausible, and failed in a way the state could not openly process. And once the human route started to break down, the next question becomes obvious. If the Soviets could not trust the crude path, did they stop going after the moon? Or did they shift to something quieter, safer, and in some ways more effective? Because what happened next is one of the most important turns in the whole story. When the humans stalled, the robots took over. If the Soviet Union could not get a person safely onto the moon, did that mean it was out of the race? No, it meant the race changed shape. And this is where the story becomes more important than most people realize, because when the human plan started to fail, the robots did not just fill the gap. In some ways, they created a more durable lunar strategy. The clearest example is Lunokhod 1. When Luna 17 delivered it to the moon in 1970, the Soviets proved they could move across the lunar surface without putting a cosmonaut at risk. This machine weighed about 756 kilograms. It had 8 powered wheels, cameras, solar panels, and a heating system that helped it survive the extreme cold of the lunar night. It was not built as a stunt. It was built to work. Over its mission, it travelled about 10.5 kilometres, sent back thousands of images, and gathered data on the soil and terrain. That matters because once a machine like that is operating successfully on the moon, the whole meaning of surface exploration starts to change. Apollo showed that humans could go there, walk there, and come back. Lunokhod showed something different. It showed that a robot could stay productive on the moon, cover distance, study the ground, and keep returning useful information without the enormous mass, cost, and risk that come with human life support. That is not a small difference. A crewed mission has to spend huge amounts of mass on keeping people alive, protecting them, and getting them home. A robotic rover can use more of its mass for mobility, instruments, power, and survival systems. That gives it a very different kind of efficiency. Then there is the control problem. Driving a machine on the moon is nothing like driving one on Earth. Even though the moon is close by space standards, the signal delay between us Earth and the moon is still enough to make direct real-time driving awkward. Operators could not just react instantly the way you would on Earth. They had to work through camera views, judge the terrain carefully, predict how the wheels would behave, and avoid getting trapped. Every movement had to be planned with delay, uncertainty, and limited visibility in mind. And the moon adds its own pressure to every decision. The ground is covered in abrasive regolith. The temperature swings are severe. There is vacuum, dust, low gravity, and long periods of darkness. So the real achievement of Lunokhod was not just that it moved. It is that it kept functioning in an environment that punishes weak machines very quickly. That is one of the most underappreciated engineering successes of the entire early lunar era. It proved that surface exploration could continue even while the crude Soviet moon plan was collapsing. That is the key shift. The Soviet Union did not stop learning about the moon just because its human landing plan was in trouble. It started learning in a different way, and in some respects that different way was better suited to sustained exploration. A rover turns the surface into measurable terrain. That is one of the most important things to understand here. A photograph tells you what a place looks like. A rover tells you how a place behaves. Lunokhod measured soil compaction, bearing strength and surface roughness. It examined rock distribution, crater edges, and mere terrain in more detail than a stationary lander could. Its wheels did not just move through the regolith, they tested it. Wheel slip, sinkage, traction, and resistance all became useful information. That may sound technical, but it matters for the future of the Moon in a very direct way. The Moon is not one uniform surface. Some areas are broad basalt plains, some are rough ejecta fields full of broken rock, some have fine deceptive regolith. Some are more stable, some are more difficult for machines to cross. Once a rover starts moving over those surfaces, geology becomes an engineering problem and engineering becomes a source of geology data. The Soviets were not just driving around. They were learning what kinds of lunar ground could support machines, how the surface reacted under load, and what terrain might be practical for longer operations later on. That kind of knowledge becomes even more important if you stop thinking about one mission and start thinking about repeat access. A single landing can prove that arrival is possible. A rover teaches you how sustained activity might work. That is a much bigger strategic question. Then there is another part of the Lunokhod story that almost never gets enough attention. One of its most important payloads was not dramatic at all. It was a laser retroreflector. That sounds simple, but its value is enormous. Scientists can fire lasers from Earth at these reflectors and measure the return with extraordinary precision. That makes it possible to track the Earth-Moon distance over time very accurately. Those measurements help scientists study the Moon's motion, the way it physically rocks and shifts, the long-term tidal relationship between Earth and Moon, and even parts of gravitational physics. That means Lunokhod kept contributing even after it stopped moving. Its mission did not end when the driving ended. It left behind an instrument that remained scientifically useful for decades. That completely changes the usual prestige story of the Moon race. The Soviets did not land the first humans, but they placed hardware on the Moon that became part of long-term precision science. That is a quieter legacy, but it is not a smaller one. And this is where the deeper meaning of the Soviet robotic program becomes clear. Once the crude route lost momentum, the Soviets did not walk away from the Moon. They pivoted. That is one of the most important hidden parts of the whole story. The public memory often reduces the Moon race to one televised victory, and after that it assumes the Soviet side simply faded out. But that is not what happened. The Soviet Union kept sending orbiters, landers, rovers, and sample return missions. It kept building a practical record of how the Moon works. That record included surface mobility, soil behavior, machine survival, sample logistics, and long-duration instrument use. In other words, the Soviets were still doing the kind of work you need if you want to understand the Moon as a place of operations rather than just a place of symbolic arrival. That is a major difference. One approach proves you can visit. The other approach teaches you how to keep going back and how to keep learning once you are there. So what were the Soviets hiding here? Not just defeat, not just the fact that the human program had stalled. They were also hiding, or at least failing to present clearly, a strategic shift that now looks much more important in hindsight. They moved from the drama of the human landing race to the persistence of robotic exploration. And persistence turned out to matter a lot. While much of the world remembered the Moon mainly through flags and footprints, the Soviets kept building knowledge about what the surface is made of, how it supports machines, how remote operations can work, and how a robotic presence can keep producing science over time. That is less dramatic in the popular memory, but it is more useful if your goal is to understand the Moon seriously. And once you see that, the tension rises again. Because if robots could survive, move, and study the Moon so effectively, then the next logical step was obvious. It was not enough to drive over the surface. The next step was to bring part of that surface back to Earth. And when the Soviets did that, the dirt itself started to reveal a new layer of the secret. The Soviet Union did not just reach the Moon with machines, it brought part of the Moon back to Earth. And that changes the story again, because once you can return lunar material automatically, the moon stops being something you only photograph and starts becoming something you can test, date, cut apart and study in a laboratory. That is why Luna 16 matters so much. In September 1970, it returned about 101 grams of lunar soil from Mare Fecunditatis. That number sounds small if you compare it with Apollo, which brought back far more material with astronauts. But that comparison can hide what made Luna 16 such a serious achievement. This mission had no crew, no one was there to fix a jammed system, adjust a procedure, or improvise if something went wrong. The spacecraft had to land on the moon, collect material, launch off the moon again, navigate back to Earth, and survive re-entry on its own. That is a very hard chain of events. The Soviets pulled it off. That success proved something important. They were not just taking pictures from a distance, they were physically extracting lunar material and studying it on Earth. That means they were building a real scientific archive while much of the broader public was focused almost entirely on the human landing story. Quietly, the Soviet program was turning the moon into something portable. A small amount of soil was enough to carry huge amounts of information once it reached a lab. And Luna 16 was not the end of that effort. It was the beginning of a pattern. In 1972, Luna's 20 returned about 55 grams of material from the lunar highlands. Then in 1976, Luna 24 returned around 170 grams from Merecrisium, after drilling deeper into the regolith than the earlier Soviet sample return missions. Those numbers are not just sample totals, they represent different kinds of lunar terrain. And once you have material from different regions, the moon stops looking generic. That is the real shift here. If you only have one sample from one kind of terrain, you learn something important but limited. Once you have samples from mare regions and from highland regions, you can start comparing different geological provinces. Mare material is mostly tied to ancient volcanic plains made of basalt. Highland material is more closely linked to the moon's older crust, including anorthositic components. So now you are not just asking what is the moon made of, you're asking which part of the moon are we talking about, what happened there and when did it happen. That is a much bigger scientific question. It turns the moon into layered history. You start seeing evidence of crust formation, giant impacts, volcanic flooding mixing by repeated bombardment, and the long, slow process by which the regolith matured over time. Chemistry stops being just chemistry, it becomes a historical record. And then there is the issue of age. Lunar samples are not only useful because of what they are made of, they are also useful because they can be dated. That is one of the biggest reasons lunar material matters so much. By using radiometric dating, scientists could estimate when volcanic activity happened in the mare regions and how old some highland materials were. Mare basalts often point to events billions of years old. Highland material can preserve even older crustal history. That turns the moon into a reference clock for the early solar system. That matters far beyond lunar science itself. Earth is a bad keeper of very ancient surface history because its geology is active. Old crust gets recycled, buried, melted, broken apart and reshaped. The moon preserves much more of that early record. So when Soviet missions brought back lunar material, they were not just bringing back dirt from another world, they were bringing back evidence about the timing of events in the early inner solar system. Impact history, volcanic episodes, crust development, all of that becomes easier to reconstruct when you can hold the sample in your hand and test its age directly. That gives every gram much more value than its mass suggests. A tiny capsule of lunar soil can help anchor entire models of planetary chronology. It can help scientists estimate the ages of surfaces not only on the moon, but also on other rocky worlds by comparing crater counts and dating benchmarks. So those small Soviet return capsules were carrying much more than a symbolic payload. They were carrying pieces of deep time. Then the story gets even more interesting, because old samples kept producing new science decades after they were collected. This is one of the best examples of why lunar material matters so much. The instruments available in the 1970s were powerful for their time, But they were not the end of the story. Later techniques became more sensitive and more precise, and when scientists went back to older lunar samples with better methods, they started finding new evidence that did not fit the older, simpler picture of the moon. One of the biggest examples is the modern discussion around lunar water and hydroxyl. The old popular image treated the moon as completely dry. Later work complicated that picture. Some lunar minerals and volcanic glasses showed measurable signs of indigenous water or hydroxyl. That does not mean a Soviet sample suddenly revealed hidden lakes or overturned everything in one step. It means older material, collected under Cold War conditions, kept becoming useful inside newer scientific debates. A sample returned in the 1970s could still matter in a 21st century argument about lunar volatiles, mantle chemistry, and what resources might exist on the moon in accessible form. That is a very important point for this story. The value of the Soviet sample return program did not end when the capsules landed. Those samples outlived the assumptions of the era that collected them. They kept speaking as science improved. That is a very different kind of legacy from a one-time publicity event. It means the Soviets were gathering material that would remain scientifically active long after the Cold War context had changed. And that leads to the deeper secret inside the soil. Once you can return lunar material automatically, the moon stops being just a destination in a race. It becomes a repeatable source of knowledge. You do not need a human being on the surface to bring back evidence about crustal composition, volcanic history, regolith structure, impact mixing, and maybe even traces of volatile behavior. That makes the moon bigger than the race itself. This is exactly the kind of thing a state might not emphasize loudly in public, while taking it very seriously in private. A flag gets attention. A small container of soil does not. But the soil can tell you what a region is made of, how old it is, how it formed, what processes changed it, and what future missions might look for there. The more carefully you study lunar material, the less the moon looks like a dead symbol and the more it looks like a laboratory, a record of solar system history, and possibly even the early map of usable resources. That is why this part of the story matters so much. The secret inside the soil was not some cinematic revelation hiding in one sample. It was the growing realization that the moon could be studied repeatedly, systematically and usefully, without waiting for humans to do everything in person. The Soviets were learning that robotic sample return could produce high-value science again and again. That changes how you think about their lunar program. It was not just an aftershock of losing the human landing race. It was part of a different, and in some ways more sustainable way of working the moon. So when you ask what they were hiding, one answer is this. They were helping reveal that the moon was scientifically richer and practically more important than the public story allowed. The dirt itself was proving it, not through spectacle, but through chemistry, age, structure, and long-term relevance. And once you realize they could bring the moon home without astronauts, another question gets harder to ignore. If they could land robots, return samples, and operate at lunar distance with real skill, then how close did they come to sending humans around the moon before anyone ever landed on it? The Soviets were practicing missions around the moon before any human ever landed on it. That matters because one of the fastest ways to make history in the moon race was not to land first. It was to send humans around the moon and bring them back alive. That would still have been a huge breakthrough. It would have shown that a country could leave Earth orbit, cross cislunar space, swing around another world and return safely. And the Soviet Zond program was aimed directly at that possibility. Zond 5 is the mission that makes this impossible to dismiss. In 1968, it flew around the moon and came back to Earth carrying biological specimens, including turtles. That sounds strange at first, but it tells you exactly how serious the mission profile was. The Soviets were not just testing a route, they were testing what a real circumlunar journey would do to living organisms. Zond 6, Zond 7, and Zond 8 followed with more work on guidance, re-entry, and recovery. These were not side projects, they were rehearsals for a possible human lunar flyby. If the system had become reliable fast enough, the Soviet Union might have tried to send cosmonauts around the moon before the Americans could secure that milestone. And that point matters because it changes the shape of the race again. The Soviets were not only trying to reach the moon with robots or trying to build a lander for the surface, they were also building the road to the moon in operational terms. They were practicing the exact kind of mission that could have changed the public story of the 1960s if it had worked at the right time. A circumlunar mission is not the same as a landing, but it is still extremely demanding. The spacecraft has to navigate all the way out to lunar distance, handle communication delays, survive radiation exposure outside Earth's protective magnetic environment, and then come back into Earth's atmosphere at very high speed. That last part is one of the hardest pieces. A return from lunar distance means re-entry at about 11 kilometers per second. That is far faster than coming back from low Earth orbit. At those speeds, errors are less forgiving, thermal stress is severe, and the entry profile has to be managed with great care. That is why the Zond missions were such serious tests. They were working through high-energy return conditions, guidance precision, skip re-entry behavior, and landing recovery. Some of those missions had serious problems. There were issues with parachutes. There were cabin integrity concerns. There were reasons to hesitate. Those details are not side notes. They are the core of the story, because they show how narrow the margin really was. A human circumlunar flight was not blocked by lack of ambition. It was blocked by the fact that these systems were still too unstable to trust with a crew. This is one of the most important things to understand about the Soviet lunar effort as a whole. So much of it was real enough to matter, but not reliable enough to convert into the clean public success that history remembers. The Zond program fits that pattern perfectly. It had real hardware, real missions, real return data, and a real strategic purpose, but the quality of the results was not strong enough to support the risk of putting people on top of that system and hoping everything behaved. The biological payloads make that even clearer. The reason the Soviets sent living organisms was simple. Deep space biology was still full of uncertainty. How much radiation would a trip to lunar distance deliver? Would a living body handle the flight well enough? Would the combined stress of deep space travel, weightlessness, and high-speed re-entry produce major damage? These were not abstract questions. They were practical barriers to any crude lunar attempt. Zond 5 helped answer some of them. The biological payload survived. Radiation measurements suggested that at least in the absence of a major solar particle event, the dose on that kind of journey might be manageable. That did not make the mission safe in any modern, comfortable sense. It did not remove the danger of space weather. It did not remove the dangers of guidance failure, re-entry error, or landing malfunction. But it did narrow the unknowns. It showed that a circumlunar mission was not beyond the limits of living biology. That is a major threshold. And this is where the secrecy becomes even more serious. The Soviets were not only testing hardware in secretive conditions, they were testing whether bodies could go to lunar distance and come back functional. They were testing whether a person could survive the road to the moon. That is a very different level of hidden effort than most public retellings allow for. So why did no Soviet crew actually fly around the moon? Not because the Soviets lacked nerve, not because they were absent from the competition. The answer was reliability. A human circumlunar mission demands confidence in every major layer of the system. Life support has to hold, guidance has to be accurate, the heat shield has to work, the parachutes have to deploy correctly. Recovery has to be credible, and ideally, your test history needs to be good enough that the system can justify the risk if something goes wrong in front of the world. That confidence never fully arrived in time. The Zond flights showed promise, but they also showed too many weaknesses, and while the Soviets were still trying to stabilize that path, the United States made its move. Apollo 8 went around the moon in December 1968. That changed everything. Once American astronauts had already circled the moon and returned safely, the Soviet chance to seize that specific first was gone. A mission that might have changed history 1 month earlier would no longer carry the same force afterward. That is one of the great almost moments of the entire Cold War. The Soviet Union was not standing far away from relevance. It was very close to a real cislunar human milestone. But close is not enough in a race like this. If your reliability comes too late, the history books do not record how close you felt. They record who got there first. And that is why this part of the story is so important. The hidden story is not just about the moon's surface. It is also about the road to the moon. By the late 1960s, the Soviets had real translunar capable hardware. They had practice missions that went around the moon. They had biological return data from circumlunar flight. They had a credible path, unstable but real, towards sending humans into cislunar space and back. That means the moon race was much tighter than the simplified public version suggests. It was not a one-sided American march toward history while the Soviets watched helplessly. It was a contest where the Soviets reached the moon's neighborhood, tested return from that distance, and came within reach of a major crewed milestone but could not stabilize the system in time. That is a much harder and more dramatic story than the clean version people usually hear. And once you see that, the next question gets larger than prestige. Because if both superpowers were building the ability to navigate, communicate, and operate at lunar distance, then the moon was no longer just a scientific target or a symbolic prize. It was starting to look like something else too, something strategic, something states would care about even if no one ever built a base there. The moon was not just a scientific target, it was also a strategic object, and both superpowers understood that much earlier than most people realize. You do not need a secret Soviet base on the moon to explain why military planners would care about it. The basic logic is enough. The moon sits in cislunar space, and anything in cislunar space forces states to think about access, communication, tracking, and control. It is a large body with predictable motion, clear geometry, and major line-of-sight consequences. Even before anyone seriously militarized it, the moon already looked like something that mattered strategically. That is because the technologies needed to reach the moon were never purely scientific. Heavy rockets, guidance systems, tracking networks, rendezvous techniques, high-gain communications, deep space navigation, and autonomous control all had obvious national security value. During the Cold War, there was no clean wall between civilian prestige, scientific capability, and strategic capability. If a country could send hardware to the moon, guide it there, maintain communication, and bring data or samples back, that country was proving much more than scientific curiosity. It was proving technical reach. That is why Soviet lunar capability mattered beyond science. Scientists absolutely cared, engineers absolutely cared, but they were not the only audience. Any state that can operate at lunar distance is showing that it can function far beyond Earth orbit in a controlled way. In Cold War terms, that is not just exploration, that is capability. Then there is the far side, which made this even more interesting. The far side is shielded from Earth's radio noise. Scientifically, that makes it extremely valuable. It is one of the best possible places for low-frequency radio astronomy, because Earth signals do not drown out faint cosmic sources there. But the exact same feature also makes the far side feel strategically charged. A place that cannot communicate directly with Earth sounds secretive by definition. It invites speculation very easily, but the reality is more demanding than the rumour. A hidden far-side operation would not be easier than a near-side one. It would be harder. You would need relay support. You would need reliable navigation. You would need more disciplined infrastructure, not less. So the far side was not attractive because it was simple to hide things there. It was attractive because its silence had both scientific value and strategic implications. If you could work on the far side, you were proving a very advanced level of control. That is an important point because it cuts through the easy conspiracy version. The moon felt charged not because strange claims were automatically true, but because the real requirements of operating there were so high. Difficulty made the place more serious. It acted as a filter. The moon was not a place where anything could happen cheaply or casually. If someone was doing something meaningful there, they had to build a lot of capability first. That made every real step matter more. And the Soviet Union was building exactly that kind of capability. To track and command lunar spacecraft, it needed a real deep space network. That meant powerful ground stations, large antennas, long-range communications, and control systems that could follow hardware far beyond low Earth orbit. Facilities like Yevpatoria were part of that backbone. Once you build that kind of infrastructure, you are doing more than sending probes. You're creating a national system for operating in deep space. That has strategic meaning even if the missions are peaceful. In Cold War logic, capability itself is often the message. A state that can track, command, and communicate at lunar distance is showing that it can project technical power into regions that most countries cannot even reach. It is demonstrating competence in navigation, timing, signal handling, mission control, and long-range systems integration. The moon becomes strategically legible because the state has built the machinery needed to make it legible. This is one of the hidden layers of the Soviet moon story. The interesting part is not a secret weapon on the surface. It is the creation of a technological system that made the moon something a superpower could actually work with. Once that exists, the moon is no longer just a distant object in the sky. It becomes a region you can map, approach, communicate with, and potentially operate in on repeat missions. Then you have the issue of resources, and this is where the story starts to connect directly to the present. Long before modern moon plans became public and fashionable, serious people already understood that the lunar surface was not just scenery, it was material. Lunar regolith contains oxygen bound up inside minerals and oxides. That matters because oxygen is not just something you breathe. It is also a major component of rocket oxidizer. If you can get oxygen from local material, the moon becomes much more useful. Other materials mattered too. Titanium-bearing minerals such as ilmenite drew attention because they pointed toward both industrial potential and oxygen extraction possibilities. The moon also contains aluminum, silicon, iron, magnesium, and calcium in forms that are scientifically and potentially practically significant, even if extracting them would require major energy and infrastructure. Later on, helium-3 became famous in speculative discussions about fusion, although the actual concentrations in lunar soil are very low and far from easy wealth. The hype around helium-3 often runs ahead of reality, but that does not raise the larger point. Once people start asking what the moon contains and what can be processed there, the moon stops being just a destination. A superpower that studies soils, drilling methods, rover mobility, and geochemistry is not just collecting academic facts. It is asking whether the moon is usable. It is asking what can be extracted, what can support long-term hardware, what can be turned into supplies, and what kind of infrastructure might one day make sense there. That does not mean the Soviets had a finished blueprint for industrial lunar development. It means they were already gathering exactly the kind of information that would matter if the moon ever became economically or strategically active in a larger way. And that makes their robotic campaign look different. Orbiters map terrain, landers test surface conditions, rovers measure mobility and soil behavior, sample return probes reveal chemistry and age. Drills show what lies below the immediate surface. Even if the official language is purely scientific, the resulting knowledge has strategic value. It tells you where machines can survive, what regions are easier to work in, what kinds of material are present, and how difficult extraction or construction might be. That is why the hidden story here is better understood as calculation, not occupation. The Soviets were not hiding a thriving secret colony or some dramatic structure on the moon. What they may have been hiding, or at least not presenting openly, was a pattern of serious strategic thinking. What can be relayed from lunar distance? What can be observed from there? What can be extracted from the soil? What systems survive the environment? What operations can be automated? What kinds of infrastructure would be required before any larger presence becomes practical? Those questions are more credible than the fantasy version, and in some ways they are more unsettling, because they suggest that the moon was already starting to change category during the Cold War. It was moving from destination to asset, not a fully developed asset yet, and not one that could be exploited easily, but one that was being evaluated in those terms. A place with scientific value, operational value and future material value. That helps explain why the Soviets kept going even after losing the most visible part of the race. If the moon is only a stage for prestige, then losing the first human landing should make it much less important. But if the moon is also a place where you test communications, mobility, sample logistics, terrain knowledge and resource potential, then it stays important. In that frame, continuing robotic work is not just persistence, it is reconnaissance. And that is one of the strongest answers to the question of what the Soviets were hiding on the moon. Not an occupation, not a single secret object, a set of calculations, a recognition that the moon was strategically significant even before anyone could realistically control it. A recognition that studying the moon meant learning how another world could become usable, observable, and technically reachable on repeat missions. Once you see that, the Soviet lunar story looks much more modern. It starts to resemble the logic behind current lunar programs. Map first, test the ground, study the poles, understand volatiles, improve communications, increase robotic capability, and treat the moon as a place where long-term systems might matter. That logic did not suddenly appear in the 21st century. Parts of it were already there during the Cold War. And once the moon starts looking like a strategic environment instead of just a race target, another question becomes unavoidable. If it was this hard, this valuable, and this dangerous, then why did humans stop going there at all? Because the next part of the story is where the moon becomes most honest. The environment itself may have been telling both sides something they did not want to admit. The moon is close to Earth, but that can make people underestimate how hostile it really is. One of the biggest reasons human missions to the moon are so hard is radiation. People often reduce the problem to the Van Allen belts, as if once you cross those, the danger is mostly over. That is not the full picture. The belts matter, but the transit through them is relatively fast. The deeper problem begins after that, when a spacecraft leaves Earth's magnetic protection and enters a much harsher environment. Out there, crews are exposed to galactic cosmic rays and to the much more dangerous possibility of solar particle events. A solar storm at the wrong time is not just bad luck, it can become a serious medical emergency. Even without a major event, the background radiation environment on the moon is not trivial. Modern measurements make that very clear, but even in the late 1960s, the Soviets already knew enough to understand the basic point. Radiation was not a science fiction issue. It was a mission planning problem. It affected how long you could stay, how much shielding you needed, how much mass you had to carry, and how much risk you were accepting every time you sent a person beyond Earth orbit. That changes the whole mood of a lunar mission. A crewed moon flight is not just a race against fuel or time, it is also a race against exposure. Most of the time you may get away with it, but the system does not forgive a bad event. That is the key point. If the sun behaves badly while your crew is far from proper shelter, the mission can turn dangerous very quickly. So when people ask why the moon did not become a routine human destination after the first landings, this is one of the first hard answers. The environment itself is dangerous in ways that do not always look dramatic on camera. Then there is lunar dust, which sounds less impressive than radiation, but may be one of the most practical and damaging problems of all. Lunar dust is not like ordinary dust on Earth. On Earth, wind and water wear particles down. Lunar dust has no atmosphere and no liquid water to soften it. Many of the grains stay sharp, angular, and abrasive. They can cling to surfaces, work their way into joints and seals, scratch materials and interfere with mechanisms. Apollo crews reported that the dust was irritating and difficult to manage. It got onto suits, into equipment, and into the cabin environment. That matters a lot more once you apply it to the Soviet lunar plan. Their concept already had very little margin. One cosmonaut, a very tight timeline, a small lander, limited volume, limited backup options. In that kind of mission, dust contamination is not a minor inconvenience. It can affect seals, moving parts, visibility, suit performance, and operational timing. When your system is already stripped down, a practical problem that sounds boring can become the thing that starts a chain of failure. That is one of the least glamorous truths about the moon, and also one of the most important. The danger is not always in the giant dramatic event. Sometimes it is in a fine abrasive material getting into the wrong place at the wrong moment. The moon also pushes hardware to its limits through temperature. This is another part of the environment that sounds manageable until you look at the details. The lunar day-night cycle creates severe temperature swings. Surfaces in sunlight can get extremely hot. Surfaces in darkness can become brutally cold. On Earth, air and weather help spread heat around. On the moon, there is no atmosphere to smooth those changes out. That means every vehicle, instrument, suit, battery, radiator, and life support system has to deal with thermal stress in a very direct way. This is exactly why Soviet robotic systems needed heaters and carefully designed thermal protection. Lunokhod surviving the lunar night was not just a nice engineering detail. It was proof that even machines need serious thermal planning to stay alive there. For human systems, the problem is even harder. Now, you're not just keeping electronics within limits, you're trying to keep a person alive in a sealed system while also managing power, heat rejection, suit integrity, and timing. The moon is near in distance, but physically it is harsh. That gap between closeness and harshness fooled a lot of people. It feels accessible. It is not forgiving. And once you stack those environmental realities together, the Soviet one-man landing plan starts to look even more extreme. Radiation risk, abrasive dust, strong thermal stress, communication constraints, tight mass limits, and a single operator with no partner on the surface. That is one of the most severe mission concepts ever seriously pursued. It was not just risky in the normal sense, it was risky in a structural sense. Almost every part of the system had limited room to absorb trouble. One person would have to descend alone, operate alone, and ascend alone. There would be no second set of hands on the surface, no second brain right next to the problem, no large comfortable vehicle where time and options could be stretched. The whole mission depended on everything staying within narrow limits. That is what makes it so striking now. It was not only bold, it was fragile. This is where the story becomes more honest than most Cold War retellings. The secret may not be what the Soviets found on the moon. The secret may be what the moon itself told them. It may have told them that human presence there, at least with the hardware and margins they had, was much more fragile than the era wanted to admit. Prestige demanded confidence. The environment did not cooperate. And that helps explain the Soviet shift toward robots in a way that is much deeper than simple defeat. It is easy to say they turned to robots because they lost the human race. That is true at one level, but it is not enough. The deeper truth is that robots made sense because the moon was brutally honest about weak margins. A rover does not need a pressurized cabin. A sample return probe does not need life support. A robotic lander does not need to worry about radiation dose to a human body during surface operations. Machines still face thermal stress, dust, and communication problems, but they can be designed around those challenges without carrying a person through them. That does not mean robotic missions were easy. They were not. The Soviets earned every success they had, but the robotic path matched the moon better. It matched the actual environment better. It matched the engineering reality better. Once you see that, the Soviet program starts to look less like a retreat from courage and more like an encounter with facts. That is an important distinction. The moon did not reward bravado. It rewarded systems that could survive. It punished weak redundancy, tight tolerances, and optimistic assumptions. It punished hardware that was just good enough on paper. It punished designs that left no room for delay, contamination, thermal stress, or unexpected conditions. In that environment, the Soviet turn toward robotic persistence starts to look less like second place and more like the beginning of a harder kind of realism. And that may be one of the biggest hidden truths in the whole story. The Soviet Union may never have openly said it this way, but the pattern suggests something close to a strategic confession. Human lunar exploration on their terms was not just difficult, it was too close to unforgiving. The moon itself may have forced that conclusion. Not through ideology, but through exposure, dust, temperature, timing, and the constant demand for margin. That is a stronger revelation than the usual conspiracy version, because it is grounded in how the moon actually behaves. The real secret was not a strange object in a crater. It was that the moon was hard enough to break the story both superpowers wanted to tell about mastery. One side got there first and then stopped. The other side nearly built away the there and then leaned harder into machines. In both cases, the moon set the terms. And once you accept that, the next part of the story becomes even sharper. Because when people talk about anomalies on the moon, they usually mean rumours, but the moon really does have anomalies. The difference is that they are geological, gravitational and physical, not supernatural. And once you see those clearly, the moon starts looking stranger than the myths ever needed it to be. The moon really does have anomalies, just not the kind conspiracy stories want. A lot of lunar features look unnatural at first glance, and that is one reason the moon keeps pulling people into wild explanations. The surface is full of shapes that do not feel familiar if your instincts were trained on Earth. Huge circular basins, dark floored craters, long rills that can look strangely straight from some angles, central peaks rising out of impact scars, crater chains that look too neat, small dark patches that seem out of place. The human brain is very good at seeing design, even where there is none, and the moon gives that instinct a lot to work with. Some of the best examples are on the far side. Tsiolkovsky crater stands out immediately because it has a dramatic dark basaltic floor surrounded by brighter highland terrain. It looks deliberate in a way that natural geology on Earth often does not. Mare Moscoviense is another one. It is a dark mare on the far side where large maria are rare. So it feels unusual right away. These places can look like clues to hidden construction if you arrive without enough geological context. But the real explanation is better and harder. Impact mechanics, volcanic flooding, crust thickness, and basin evolution can produce forms that look stranger than fiction, without requiring any artificial origin. That is one of the central truths of the moon. It looks engineered in places because the processes that shaped it are so cleanly preserved. On Earth, atmosphere, water, and active geology blur and erase a lot of structure. On the moon, old scars and volcanic features remain exposed for extremely long periods. So geometry stays visible. Contrast stays sharp. Large structures stay readable. That can make natural features look staged or intentional when they are really the result of impact physics and ancient volcanism. Then there is a much more technical anomaly that turned out to be extremely important: mascons. These are mass concentrations linked to large impact basins, especially where dense basalt filled those basins later on. In simple terms, some parts of the moon pull harder than mission planners first expected. The moon's gravity field is not smooth. It has lumps and imbalances. That means a spacecraft in lunar orbit does not move through a perfectly simple gravitational environment. That turned into a real operational problem. Early lunar orbiters showed that low lunar orbit could behave in ways that were more unstable than people expected from a naive model. Orbits could drift. Low points in the orbit could shift. Long-term stability could become difficult to maintain depending on where the spacecraft was flying. That sounds like a technical issue, but it changes the whole mood of lunar exploration. The moon was not just sitting there waiting politely for spacecraft to circle it. Its internal structure was affecting their paths. This matters a lot because it shows how the moon could produce real danger while also feeding myths. A spacecraft's orbit changes unexpectedly, and people start reaching for secret explanations, but the explanation was already dramatic enough. The moon's uneven interior mass distribution was warping the trajectories of machines sent to study it. The danger was real. The reason was gravity. And this is exactly the kind of thing that makes the real moon stranger than the fake version. You do not need a hidden machine in orbit or a secret defense system to make a spacecraft's path go wrong. You just need a world whose gravity field is more complicated than people expected. That is what mascons revealed. The moon was hiding traps, but they were geological and gravitational, not artificial. The same pattern appears when you look at lunar volcanism. The dark maria are not just dark patches. They are huge basalt plains left by ancient eruptions. The moon had a volcanic history large enough to flood major basins with lava. Some of the long winding rills on the surface are thought to be linked to lava flow pathways or collapsed volcanic channels. That already makes the moon much more active in its past than the old simple image suggested. And modern thinking goes further. Scientists also take seriously the possibility of lava tubes and other subsurface voids on the moon. These are not fantasy spaces hidden by aliens. They are natural geological structures that can form when lava flows in ways that leave underground passages or hollow sections behind. Soviet-era missions did not directly prove giant habitable underground spaces, but Soviet mapping and sample work helped build the larger picture of a moon with an extensive and uneven volcanic history. That is the real anomaly here. Not hidden civilization, but hidden process. A relatively small world that once moved enough magma to reshape huge areas of its surface. That matters because it completely changes how the moon looks once you know what you are seeing. A dark plain is no longer just a dark plain. It becomes evidence of large ancient eruptions. A rillet is no longer just a line. It may be a volcanic pathway or a collapsed structural feature. A basin is no longer just a hole. It may be a site where impact history and volcanic history overlap. The more you understand the moon geologically, the less ordinary it becomes. Crater chains make this even clearer. Some chains are not signs of deliberate placement or hidden runway-like structures. They can form when debris thrown out from a large impact falls back in patterned sequences. Secondary impacts can create clusters and chains that look too organized if you do not know how ejecta behaves. The same is true for impact glass and fused regolith. These materials can reflect light in odd ways and create visual effects that look strange, especially in low-resolution images. And that point matters a lot when you think about early lunar photography, including Soviet images. A blurred or low-contrast image of an unusual feature is not evidence of a secret structure. It is evidence that the moon was being seen with limited tools for the first time. Illumination angle also matters enormously. Low light can stretch shadows, exaggerate ridges, and create apparent symmetries that seem convincing until you study the geometry more carefully. The moon is one of the easiest places in the solar system to misread visually if you do not know how impact geology and lighting work. That does not make the moon less interesting, it makes it more interesting. Because the correction is not that everything strange is fake. The correction is that the strange things are real, but they come from geology, volcanism, gravity, impact physics, and preservation conditions that have very few true equivalents on Earth. The moon is weird in the honest scientific sense. That is the strongest version of this section. The truth is sharper than the myth. The moon really is full of anomalies. It has uneven gravity. It has strong hemispheric differences. It has patchy volcanism. It preserves impact structures with unusual clarity. It has terrain and forms that can look engineered until you understand the processes behind them. None of that needs to be exaggerated. It already shatters the old simple picture. And that is why Soviet lunar exploration matters so much here. The Soviets were not just pointing cameras at a blank rock. They were mapping and sampling a world that kept refusing to behave like a simple dead sphere. Every new image, every sample, every terrain measurement pushed the moon further away from the old textbook model. The farther they looked, the less ordinary it became. So when people ask what the Soviets were hiding on the moon, one answer is this. They were helping uncover a world whose real natural history was already strange enough to feed myths for generations. But the more serious question comes next. Because sometimes the biggest mystery is not the strange thing itself, it is the silence around it. And in the Soviet lunar program, that silence became a machine for making legends. The biggest mystery in the Soviet moon story was often not a strange event on the moon. It was the silence after things went wrong. That silence matters more than people usually think. In a more open system, failure leaves traces. There are reports, press coverage, public arguments, technical reviews, and a visible record of embarrassment. In the Soviet system, failure often vanished from public view. If a probe failed before it really got underway, if a lunar shot missed its path, if a lander crashed, If a booster exploded, the outside world might get almost nothing clear. The program would move on, and the public story would stay smooth. That kind of silence changes the way history gets remembered. When something disappears without explanation, people do not just forget it. They start filling the gap. Was it a hidden success? A lost crew? A strange discovery nobody was allowed to talk about? Over time, people stopped separating two very different possibilities: a censored engineering failure and an extraordinary hidden event. That is one of the main reasons moon myths lasted so well around the Soviet program. The system trained people to assume that missing information meant hidden meaning, and in a way that reaction was understandable. The Soviet Union had a real reason to hide failures. Lunar exploration is full of them. Rockets fail, guidance fails, re-entry systems fail, landing systems fail. When a government treats those failures as unacceptable to discuss clearly, the result is predictable. It creates an environment where fantasy can feed on genuine secrecy. Then you add the far side of the moon, and the mystery gets stronger almost automatically. The far side cannot communicate directly with Earth without relays. That is just geometry. But in the Cold War imagination, that technical fact became extremely powerful. A place already far away, already difficult to reach, and naturally cut off from direct radio contact sounds like the perfect place for hidden events. It almost invites that kind of thinking, but again, the reality is more useful than the myth. The far side was not magically easier to hide activity on, it was harder to operate on at all. To do serious far side work, the Soviets would have needed strong communication support, reliable tracking, and enough infrastructure to keep the mission under control even when direct Earth contact was impossible. That is the real limiter. Not imagination, but infrastructure. The far side felt like a natural secret keeper, but in practice it was a technically demanding environment that filtered out weak systems very quickly. That distinction matters because it lets you keep the tension without lying about the history. Yes, the far side encouraged rumours. Yes, its blackout conditions made people suspicious, but the reason it mattered strategically and scientifically was not because anything could happen there easily. It was because meaningful activity there required a very high level of capability. That makes it more serious, not more magical. This is also the point where one of the most persistent Cold War myths has to be handled clearly. The lost cosmonaut stories have been around for decades. The basic idea is that Soviet crews died in secret before the official record could admit failure. Some versions involve distress calls, some involve hidden launches, some involve lunar missions that supposedly never came back. These stories survive because emotionally they fit the era. A secretive state, a dangerous space race, missing records, and a public that already knows many failures were buried. On the surface, it sounds plausible. But when historians compare those stories against what is known about Soviet hardware, launch records, recovered archives, and the actual maturity of the spacecraft involved, the stories do not hold up. There is no solid evidence that the Soviet Union secretly sent cosmonauts on doomed lunar missions and erased them from history. That is important to say directly, and it does not make the real story weaker. It makes it stronger, because it shows that a real culture of concealment can create fake legends that distract from the hidden truth that actually matters. The genuine hidden history was not a secret graveyard of erased lunar crews. It was a much larger catalogue of failed attempts, unstable systems, internal rivalries, and strategic adaptation. Many lunar attempts failed. The N1 failed repeatedly. Human lunar hardware existed, but never matured into the kind of reliable operational system that a real landing demanded. Design bureaus competed. Technical bottlenecks became problems. The public record was incomplete not because it was protecting one giant forbidden secret, but because the whole structure of the system was built to hide messy failure. That is the real missing record, and it changes the entire era once you see it clearly. The Soviets were not hiding one dramatic thing on the moon. They were hiding a pattern. They were trying, failing, adjusting, and continuing. They had real capability. They had real ambition. They had real hardware. They also had repeated failure and no good public language for admitting it. So the official story became structurally misleading. It showed enough success to preserve prestige, but not enough failure to preserve reality. And that is why the silence itself becomes evidence, not evidence of fantasy, but evidence that the official version was never designed to carry nuance. At some point, the question has to change. Instead of asking, what did they hide out there? You have to ask, what kind of system produces this much lunar capability and this much missing public history at the same time? That is the better question because it leads to a more serious answer. The Soviet moon program had enough substance to matter and enough secrecy to distort memory. That combination is what gave it such a long afterlife. The science was real, the missions were real, the failures were real, the missing public record was real too. And when you put those things together, the myths become easier to understand without becoming true. This is also where the story shifts from mystery into critique. The problem was not just that facts were hidden. The problem was that history itself got edited. The American side remained highly visible because so much of it happened in public. The Soviet side became harder to see because too much of the struggle was buried. That made the whole moon race look simpler than it was, cleaner than it was, more final than it was, but it was never that clean. The silence around the Soviet program was not empty space. It was a missing layer of real history, a hidden record of launches that failed, hardware that almost mattered, robots that kept working, and a lunar campaign that did not fit the easy ending most people inherited. And once that missing record starts coming back into view, the next question gets even larger. If the Soviets were already treating the moon as something worth this much effort, secrecy, and persistence, then what kind of world did they think it was becoming? Because the next part of the story is where the moon stops looking like a Cold War target and starts looking like something much more modern, a resource world. The moon started to change meaning once scientists stopped looking at it as scenery and started looking at it as material. That is one of the biggest shifts in this whole story. For a long time, the moon was treated mainly as a place to reach, a place to photograph, a place to land on, a place to plant symbols. But the more data came back, the harder it became to keep seeing it that way. The moon is not rich in convenience. It does not hand you easy fuel or easy air or easy shelter, but it is not poor in material, and that difference matters. Lunar regolith contains oxygen locked inside silicates and oxides. That means one of the most important resources on the moon may not be something dramatic like a glowing energy source. It may be oxygen that can be extracted if you have enough energy and the right processing system. Oxygen matters for breathing, but it also matters for rocket oxidizer. That alone changes how serious the moon becomes. If local material can be processed into something useful for life support or propulsion, then the moon is no longer just a destination. It starts to look like stockpiled raw material, and oxygen is only part of it. The lunar surface also contains aluminum, silicon, iron, calcium, magnesium, and titanium-bearing minerals. That does not mean these materials are easy to extract. They are not. The energy cost is high, the engineering is difficult, and nothing about industrial work on the moon is simple. But the key point is that the materials are there. Once Soviet missions started characterizing soils, comparing regions, testing regolith behavior, and bringing samples home, the moon stopped being only a place on the map. It became inventory. That is a very different way to think about exploration. Once a superpower starts asking what a world is made of in practical terms, the mission changes. You're no longer just asking where you can land. You're asking what is under the surface, what can be processed, what can support a machine, what can support a future system, and what might reduce the need to carry everything from Earth. Then there is the issue of the poles, which became even more important later. Modern missions made it much clearer that permanently shadowed regions near the lunar poles can preserve water ice and other volatiles at extremely low temperatures. The Soviet era did not have the full set of data we have now. It did not have today's hydrogen maps or later impact results that gave stronger confirmation. But the underlying idea was already serious. The moon's poles include places where sunlight barely or never reaches the surface, and if those regions stay cold enough for long enough, volatile materials can survive there. That possibility changes everything. Water is not just drinking water. Water can support life support systems, provide shielding mass, and be split into hydrogen and oxygen for propellant if the infrastructure exists. So the moment a world starts looking like it might contain preserved volatiles in usable locations, settlement logic changes. You stop thinking only in terms of brief visits and start thinking in terms of footholds, supply chains, and long-term survival. This is where the Soviet story connects directly to the modern one. The Soviets did not have full confirmation of polar ice in the way later missions would provide it. But they were among the early generations of planners and scientists forced to ask the right question. Not just what information the moon holds, but what infrastructure potential it might hold. That is a major change in mindset. It means the moon is no longer just an object of study. It starts becoming a place where material conditions might matter for future operations. Then there is helium-3, which always enters this conversation sooner or later. Helium-3 is real. It exists in lunar regolith because of implantation by the solar wind over long periods. That part is true, but the popular version often goes too far. The concentrations are usually extremely low, often measured in parts per billion. Extracting it at industrial scale would mean processing huge amounts of soil. That makes it a much weaker near-term economic case than many popular stories suggest. Still, helium-3 matters for one reason. It shows how quickly the public conversation changes once the moon starts being seen as material instead of scenery. Once that shift happens, people begin talking about mining, strategic control, energy resources, and industrial futures. The details may get exaggerated, but the direction of the change is real. The moon becomes part of a resource conversation, and that is one of the hidden legacies of Cold War lunar science. Both superpowers helped move the moon into that category, even before most people fully noticed it. When you look back at the Soviet robotic program through that lens, the pattern becomes much clearer. Orbiters map terrain, landers test surface conditions, rovers study mobility and soil behavior, sample return probes compare different geological provinces, drills go beneath the top layer. Each of those missions can be described in purely scientific language, and that is fair because the science was real. But the resulting knowledge is also exactly the kind of knowledge a long-term practical program would need. That does not mean the Soviets had a complete mining plan hidden in a drawer. It does not mean they were one step away from industrial development on the moon. But it does mean they were collecting foundational knowledge. They were learning what the ground is like, what the chemistry looks like, how different regions compare, how machines perform, how samples can be moved, and how a remote campaign can build useful understanding over time. That is what prospecting looks like in early form, even when it is still called exploration. And that is why this section matters so much. It expands the whole story beyond Cold War prestige. Once the moon becomes a place where oxygen, metals, volatiles, and engineering conditions matter, lunar missions stop being only symbolic acts. They become reconnaissance for a future economy and a future strategic environment. That does not mean the future arrives immediately. It means the first serious groundwork begins much earlier than most people think. The Soviets were not alone in that. American lunar science pointed in the same direction in many ways. But the Soviet role is easy to miss because their robotic campaign happened with less public attention and less dramatic storytelling. That can make it look smaller than it was. In reality, their repeated lunar work was part of a much larger transition. The moon was slowly being reclassified in the minds of serious planners, not as a dead rock you visit once, but as a world whose terrain, chemistry, and environment might eventually support repeat operations. That is one of the strongest answers to the question of what they may have been hiding. Not a miracle discovery, not an impossible machine, something more important and more believable. They may have understood earlier than the public did that the moon was becoming more than exploration. It was becoming a place of materials, infrastructure questions, and long-term strategic value. Their missions were helping define that shift even when the public still thought mainly in terms of flags and footprints. And once you see that, the whole Soviet lunar effort starts to look different. The probes, rovers, sample returns, and soil studies no longer feel like leftovers after losing the main race. They start to look like the beginning of a different race, one that would matter later. A race to understand what the moon is actually useful for. That is why this story matters now. A lot of what sounds modern in today's lunar plans was already taking shape in older form during the Soviet era. Questions about oxygen extraction, polar volatiles, remote operations, terrain access, and material use are not new. They are the continuation of a much older process. The Soviets were part of that process, quietly, persistently, and with much less public credit than the visibility of Apollo would leave you expecting. And that leads directly to the next part of the story. Because if the Soviet Union already understood that the moon still mattered after America's first landing, then the race did not really end when most people think it ended. It changed form, and the Soviets kept going. The Soviet moon program did not end when America won the first landing. It just became harder to see. One of the clearest proofs is Lunar 15. While the world was focused on Apollo 11 in July 1969, a Soviet spacecraft was also at the moon. Lunar 15 was there trying to complete a robotic sample return mission. It did not succeed. It crashed. But the timing tells you everything. At the exact moment the United States was preparing to put humans on the lunar surface, the Soviet Union was still trying to pull off a different kind of lunar first. That is one of the most dramatic overlaps in space history, and most people barely know it happened. That overlap destroys the simple version of the moon race. The Soviets had not stepped away. They had not accepted that the moon no longer mattered. They were still there, still operating at lunar distance, still treating the moon as an active target for science and prestige. The difference was that their method was no longer centered on the same kind of spectacle. America was trying to land people. The Soviet Union was trying to return material with machines. Same world, same moment, completely different strategy. And that was not a one-time last effort. After Apollo 11, the Soviets kept going. Lunar 16 returned samples in 1970. Lunar 17 delivered Lunokhod 1 that same year. Lunar 20 returned material from the highlands in 1972. Lunar 21 delivered Lunokhod 2 in 1973, and that rover travelled much farther than its predecessor, around 37 kilometres, showing that Soviet surface mobility was becoming much more capable. Lunar 22 continued orbital work with imaging and geodetic measurements. Lunar 24 returned drilled samples in 1976. That is not a fading program, that is a continuing campaign. This part matters because a lot of people think the moon story basically stops after the first American landings. In public memory, the narrative becomes very narrow. America landed, planted flags, brought astronauts home, and that became the whole picture. But the actual history is much wider than that. The Soviet Union kept exploring the moon through the 1970s in a consistent and productive way. The visibility was lower. The public excitement was lower. But the work kept going. And that changes how you should read the Soviet program after Apollo. It is easy to frame it as second place trying to salvage meaning after losing the human race. That is too shallow. A better way to see it is this. Once the Soviets lost the most visible kind of prestige, they adapted toward a mode of exploration that could still produce a lot of science. Robots do not create the same emotional effect as astronauts, but they can create a strong stream of data over time. Under pressure, that matters. This is one of the deepest truths in the whole story. Human lunar landings create unmatched symbolic impact. But robotic systems can be better for repeated scientific work, especially if you are constrained by risk, money, or unstable launch capability. The Soviet post-Apollo program starts to look much more coherent once you see that. Repeated landers, rovers, orbiters, and sample return missions let them gather soil data, terrain behavior, geochemical information, operational lessons, and long-lived instrument results. That does not erase the failure of the crude moon plan, but it does reframe what happened next. The race for spectacle may have been lost. The race for sustained interaction with the moon did not end. That is a major shift in perspective, because it means the Soviet story after Apollo was not just about disappointment. It was also about continuity. They kept learning how to land automatically. They kept learning how to move on the surface. They kept learning how to drill, collect, return and compare samples from different regions. They kept building practical knowledge about what the moon actually requires from machines. And when you look at modern lunar strategy, that starts to seem much more important than older public memory allowed. A real long-term lunar future depends on exactly the kinds of things the Soviets emphasized after the human race was effectively lost. Automated landing, surface mobility, remote operations, sample logistics, drilling, repeat missions, and the ability to gather useful information without sending a crew every time. That is why the hidden significance of the Soviet campaign is larger than it first appears. Apollo proved that humans could go to the moon. The Soviet robotic chain proved that machines could keep working there. And if you are serious about the moon in the long run, you need both of those ideas. You need crewed presence, and you need robotic persistence. You need dramatic milestones, and you need repeatable systems. In that sense, the Soviet lunar campaign looks much more modern now than it did to many people at the time. This is where the story really changes shape. The common version says the Soviets lost and the moon story moved on without them. But the deeper version is that they shifted into a lower visibility model that was in some ways closer to the future. Their missions emphasize precisely the things that later generations would recognize as essential. Scout first, map carefully, land automatically, test the surface, move machines across terrain, collect samples, compare regions, build operational knowledge, and treat the moon as a place you work with repeatedly, not just a place you visit once for glory. That means their lunar logic survived even if their system did not. That is the real shock here. A lot of the things modern lunar programs care about most now sound very close to what the Soviet robotic program was already doing in earlier form. Robotic precursors, teleoperation, repeat access, sample return, terrain analysis, infrastructure scouting, resource-minded science. None of that feels outdated anymore, it feels current. So when people ask what the Soviets were hiding on the moon, one answer may be this: they were already participating in the beginning of the moon's real future. Not the future of a single heroic visit, but the future of long campaigns of machines learning how to survive, move, measure, and stay useful on another world. That future is less dramatic on television, but it may matter more in the end. And once you understand that, the final twist becomes even sharper. Because when the archives finally opened wider, the truth that came out was not smaller than the myths. In many ways, it was more damaging. Not because it revealed fantasy, but because it revealed just how real the attempt had been, and how much of it had been hidden in silence. When the Soviet archives opened more fully, the truth that came out was not a secret victory, and it was not a fake program either. It was something much more uncomfortable. The lunar effort was real, technically serious, and much more advanced than the public had been allowed to understand, but it was also much more troubled. That combination is what makes the story hit so hard. The Soviets were not pretending to go to the moon. They were genuinely trying. They built hardware, tested systems, planned missions, and pushed forward. But they were doing it inside a structure that kept making success harder. After the Soviet Union collapsed, more of that record became visible. Historians, engineers, museums, and recovered documentation started filling in the missing picture. You could see more of the N1 story, you could see more of the LK lander. You could see internal planning, rivalries, design decisions, and the stop-start pattern of the entire effort. And once those pieces came together, the public story looked badly incomplete. The Soviet moon program had real engineering substance. It also had deep institutional weakness. That is more damaging than the myth because it means the loss was not clean or inevitable. It was a real possibility that broke down inside a flawed system. This is where the story stops being only about rockets and starts being about power. Cold War space history is often told like a contest of machines. Saturn V versus N1, Apollo versus L3, but that is only part of it. Bureaucracy was in the race too. The Soviet lunar effort suffered from divided authority, competing design bureaus, conflicting priorities, and arguments over propulsion strategy. Those were not background details. They shaped the hardware itself. The N1 is one of the clearest examples. Its many engine-first stage is often described as a technical oddity, but it was also the product of institutional reality. The Soviets did not have a giant engine path available in the same clean way the Americans did for Saturn V. What they had was a mix of technical possibilities, constraints, and organizational competition. So the moon rocket inherited the structure of the state that built it. That is one of the hardest truths in the whole story. The architecture was not only engineering, and once you see that, the old myth of smooth central planning falls apart. The Soviet Union projected an image of control, but the lunar program shows something much messier. Rival designers fought for influence. Important decisions were shaped by who controlled what resources and what designs could actually be pushed through the system. The result was not a single clean national push. It was a powerful but unstable effort that carried the limits of its own institutions all the way into the hardware. Then there is the surviving machinery itself, and this is where the whole story becomes almost painful to look at. When you see the LK lander and related systems in museums or engineering records, the point becomes impossible to ignore. This was not vapor. This was not a bluff. Metal was cut. Components were assembled. Procedures were written. Test articles existed. Some hardware flew in test contexts. The Soviet moon landing attempt was real enough that you can stand in front of its remains and feel how close it came to being part of ordinary history instead of hidden history. That is why these artifacts are so powerful. They do not just prove that a program existed, they prove that an alternate path was physically taking shape. Not guaranteed success, not a missed triumph waiting to happen, but a real branch of history that got close enough to leave hardware behind. That gives the whole story weight. The thing that was hidden was not just a rumour about what might have been going on. It was a serious attempt that reached the point where you can still see its body long after the system that concealed it is gone. And then the statistics make the story even harsher. Once more of the archival record becomes visible, the number of failures changes the meaning of everything else. Many Soviet lunar attempts failed at different stages. Some never got properly underway. Some failed during launch. Some missed the mission they were built for. Some reached space but not success. The N1 failed again and again. Lunar exploration on the Soviet side was not a smooth line with a few bad days. It was a repeated collision with one of the hardest technical problems any state had ever tried to solve. That does two things at once. First, it makes the successful Soviet missions even more impressive, because now you can see the scale of the struggle that surrounded them. Second, it makes the official silence more revealing, because the public was never supposed to see how much failure still had been absorbed behind the curtain. The hidden record is not just that the Soviets failed a lot. It is that they kept pushing, kept rebuilding, kept launching, and kept trying while protecting the image of seamless competence. That matters because it changes how success itself looks. Success that emerges from a long field of hidden failures means more than a success presented as clean mastery. It shows how hard the moon really was. It shows how much friction the program was carrying. It shows how much punishment the Soviet effort absorbed in private. And it shows that the public story was structured to remove the cost from the record while keeping the achievement. This is why the archive story does not reduce the mystery. It relocates it. The mystery is no longer a fantasy about something impossible hidden in a crater. The mystery becomes more serious than that. It becomes a question about how states edit memory. How much real history can disappear when power decides that failure is not part of the story? How many attempts can be buried before later generations mistake missing records for missing events? How much ambition, embarrassment, persistence, and institutional weakness can sit behind a clean official narrative before the whole era starts to look different? That is the adult version of the mystery, and it is stronger than the myth. What the Soviets were hiding was not a miracle. They were hiding the messy path of a real attempt. They were hiding how close they came in some areas, how badly they broke in others, and how much the moon extracted from them in money, hardware, prestige, and confidence. The archives make the story more human, but also more disturbing. because they show that the gap between public memory and real effort was much larger than most people understood. And once you see that, the final question stops being mysterious in the old cheap way and becomes much sharper. If the Soviets were hiding failure, persistence, science, a strategy, and a whole alternative way of approaching the moon, then what exactly were they hiding on the moon? The answer to that is bigger than any conspiracy. So what were the Soviets hiding on the moon? The first answer is simple. They were hiding failure, not one failure, a pattern of failure. Failed launches, crashed probes, missed opportunities, and a human landing plan trapped behind a rocket that would not become reliable in time. That matters because hidden failure changes the shape of history. It makes one side look stronger than it was, the other side look weaker than it really was, and the whole race look cleaner than it ever was. Once you put the missing failures back into the story, the moon race stops looking like a straight line. It becomes a brutal competition full of technical breakdowns, rushed decisions, and systems pushed past comfort. America still landed first. That does not change. But the Soviet side no longer looks like a non-event. It looks like a real lunar campaign that kept colliding with its own limits while hiding the damage. That hidden damage is one of the biggest things they were keeping from the world, because it made the final result look more absolute than it really was. But was failure the only thing they were hiding? No. They were also hiding how much real lunar science they kept doing after most people stopped paying attention. That is the quieter part of the story, but in some ways it is even bigger. After the symbolic race was lost, the Soviet Union did not walk away from the moon. It kept mapping, landing, drilling, returning samples, driving rovers, and building long-term measurements. It kept gathering information from different kinds of terrain. It kept learning how the surface behaves under machines. It kept adding to geodesy, soil mechanics, and remote operations. In plain terms, it kept studying the moon, while public memory was already moving on. That means the hidden story was not only about what they failed to do, it was also about what they kept doing. A lot of real lunar knowledge came from missions that never got the cultural weight they deserved. The public remembered flags and footprints, the Soviets kept building data. And because that work was less visible, it became easier to underestimate. But a rover track, a drill core, or a returned sample can matter for decades if it changes how scientists understand another world, and that leads to the next answer. They were hiding that the moon was not just a trophy, it was a physical system with real strategic value. By the end of this story, the moon should not feel like a blank rock anymore. It is a place with dangerous radiation, abrasive dust, difficult temperatures, uneven gravity, preserved impact history, volcanic provinces, and materials that may matter for long-term use. It is a place where machines behave differently, where communications become part of mission design, and where every landing teaches you something about how another world actually works. That is much bigger than a prestige target. The Soviets were among the first to learn that exploring the moon means studying a whole environment, not just visiting a location. A rover moving across the regolith is not just transportation, it is a test of terrain. A sample return is not just a box of dirt. It is chemistry, age, and planetary history in your hands. A far-side image is not just a picture. It is evidence that the moon's two halves tell different stories. Once that becomes the frame, the moon stops looking like the end of a race and starts looking like the beginning of a new domain. And then there is the strangest answer of all. They were hiding that the moon itself was changing the old worldview. The moon that emerged from Soviet and American exploration was not the simple moon from older textbooks. It was not just a dead uniform sphere hanging quietly over Earth. It turned out to be asymmetric. It had deep internal differences between the near side and the far side. It preserved the violent history of the early inner solar system. It had a seismic record. It had ancient volcanism on a much larger scale than many people assumed. It had regions with a different chemistry, different crustal structure, and different operational meaning. That is the real scientific shock in this whole story. The hidden revelation was not one secret object in one crater. It was that the moon itself was more complicated than the old world had been told. The more carefully it was studied, the less simple it became, and that matters because the Soviet program was part of that shift. Even when the world mostly remembered American triumph, Soviet missions kept helping uncover a moon that was physically richer, harder, and more important than the public story allowed. So why does this matter now? Because the moon is back, and this time the old simplified version is not enough. Now people talk openly about water ice, polar operations, long-duration robotics, sample return, radio astronomy, cislunar navigation, and future infrastructure. Those are not distant fantasy topics anymore. They are active goals. Major powers are planning around them now, and that means the Soviet moon story is not just a Cold War side note. It is an early chapter of the future reopening in front of us. That is why the strongest answer is bigger than conspiracy. The Soviets were hiding the cost of reaching the moon. They were hiding how often the path broke. They were hiding how much science continued after public attention faded. They were hiding how much the moon was becoming valuable as data, terrain, material, and strategy. And above all, they were hiding the fact that the moon was never just a destination. It was the first other world that forced superpowers to admit, even if only in private, how little they actually understood. And that is the real end of the story. Not that the Soviets found something impossible on the moon. It is that the moon exposed something uncomfortable on Earth. It exposed how power hides failure, how history gets simplified, and how a world can be publicly treated like a symbol, while privately being studied as the beginning of something much larger. Once you see that clearly, the question changes for good. The moon was never just where the Cold War went. It was where the future quietly started. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.